Hello guys, this is the second part of past paper physics of Cambridge, AS level 9702-12 May June 2018. Question 21. The graph shows the length of a spring as it is stretched by an increasing load. What is the spring constant of the spring? As you know, a spring constant, if you have length and load, then you can use Hooke's law, F equal to Kx. So what is K? Equal to F over X. So F over X, what is force? Suppose we consider 2 points, for example 10 and 15, and extension will be 15 minus 10, which is 5 centimeter. So you can write 5 times 10 to the power negative 2, change to meter. And force, it was 0 first, so when x1 is equal to 10 centimeter, force will be 0, and when final length become 15 centimeter, then force become 0.4 Newton. So if you subtract, you will get 0.4. So the final answer will be 8 Newton per meter. So D is right. Question 21, D is right. Question 22. Two lasers emit light in a vacuum. One laser emits red light and the other emits green light. Which property of the two laser beams must be different? Okay, in this question, you know that color depends on frequency. So color of light depends on frequency. That's why B is right. B is right, because color of light depends on frequency of light. Question 23. The diagram shows the screen of a cathode ray oscilloscope, CRO, displaying a wave. The time base of the CRO is set as 10 millisecond per division. What is the frequency of the wave? Okay. First of all, we should find time for one complete oscillation, which is called time period. So time period will be, as you can count squares for one complete oscillation, 1, 2, 3, 4, nearly 4. So nearly 4, a little bit more than 4, but we consider 4, and then after finding result we approximate. 4 square times time base is 10 milliseconds. So the answer will be 40 millisecond. So this is time period. And you know that frequency is equal to 1 over time period. So it is 1 over 40, and instead of milli, you can write 10 to the power negative 3. So the result is 25, which approximately you can consider 24, because we don't have 25 in the choices. So D is right. Question 23, D is right. Question 24. A string is fixed at one end and the other end is attached to a vibrator. The frequency of the vibrator is slowly increased from 0. A series of stationary waves is formed. Assume that for a stationary wave there is a node at point P. what are the first 5 wavelengths of the stationary waves that could be formed? Okay. As you know, first harmonic, which is called fundamental, will create 2 nodes and 1 antinode. Distance between 2 nodes is half a wavelength, and from P to fixed point the length will be L, length of the string. So L will be equal to lambda over 2. If you do cross multiplication, you can find lambda. Lambda becomes 2L. Do for second harmonic. For second harmonic, again, the length will be length of the string, which is L, but there are 2 antinode and 3 nodes. That's why length will be 2 times lambda over 2. So if you do cross multiplication, you will get lambda equal to 2L. Now, for third harmonic, lambda will be 2L divided by 3. That's why you can add, for fundamental, you can add denominator of 1. For second harmonic, denominator of 2. For third harmonic, denominator of 3. For fourth harmonic, denominator of 4. And for fifth harmonic, you can add 5. So first harmonic, lambda is 2L. The second harmonic, lambda is 2L divided by 2. Third harmonic, 2L divided by 3. 2L divided by 4. 2L divided by 5 for fifth harmonic. So that's why A is right. Question 25. Which region of the electromagnetic spectrum has waves of wavelength 1000 times smaller than the wavelength of visible light? So this is electromagnetic spectrum. Start from radio wave, then microwave, infrared, visible, ultraviolet, X-ray, and gamma ray. Approximately for radio wave, I can say that wavelength is 10 to the power 6 meter to 1 meter. For microwave, it is 10 to the power negative 1 to 10 to the power negative 2, and somehow is more or less. That's why I didn't consider that. For visible light, 10 to the power negative 6 to 10 to the power negative 7 meter. For X-ray is 10 to the power negative 10, 10 to the power negative 11, even 10 to the power negative 9. But if you consider 10 to the power negative 10 and you subtract wavelength of X-ray to wavelength of visible light, you will get 10 to the power negative 10 divided by 10 to the power negative 7, which is 10 to the power negative 3. So it means that wavelength of X-ray is 1000 times smaller than the wavelength of visible light. That's why D is right. Question 25, D is right. Question 26. The diagram shows apparatus for the measurement of the frequency of a sound wave. Sound of the unknown frequency is reflected back from a metal plate. You know that when a sound reflected back from a metal plate is a hard object. So a stationary wave is created. Okay. The continuing question. A microphone placed at a distance d from the metal plate detects the sound intensity. A minimum intensity is detected with 12 centimeters. The plate is moved further away from the microphone until the next minimum is detected with 15 centimeters. Okay. The speed of sound in air is 336 meters per second. What is the frequency of the sound? So we can say that from first minimum to second minimum, there will be one antinode. And as I said in previous questions, the distance between the node and node, the next node, will be half a wavelength. That's why half a wavelength equal to 15 minus 12, which is 3 centimeter. So if you do cross multiplication, wavelength will be 3 times by 2, which is 6 centimeter. You know that F equal to V over lambda. So V is 336 meter per second and lambda is 0.06 meter. That's why you will get 5600 hertz for frequency. So C is right. Question 27. An astronomer observes a light from a star that is moving away from the Earth. For the observed light, what has been increased due to the star's motion? Okay. First of all, we know that distance between two consecutive wavefronts is called wavelength. Okay, and then in Doppler effect, when a source is moving towards an observer, for example in this figure observer A, so in the left part waves squashed, and in the right part towards observer B waves stretch. So that's why to the left for observer A wavelength will decrease, and for observer B wavelength increase. That's why for this question we can say that wavelength will increase. So for the observed light, wavelength will increase. That's why question 27, D is right. Question 28. The diagram shows a stationary wave at time t equals 0 that has been set up on a string fixed between points P and S. Okay. The nodes of the stationary wave occur on the string at P, Q, R, and S. Point X is moving down at time t equals 0. The points on the string vibrate with the time period t, and maximum amplitude is 2 centimeter. The displacement is positive in the upward direction. Which graph best shows the variation with t of the displacement S of point Y on the string? First of all, if X is exactly in the middle of P and Q, so it is antinode. If X moves down, then in the middle of Q and R, particle moves up, and then in the middle of R and S, particle moves down. Because of that, D and C will be wrong, because between R and S displacement should be negative. We should choose between A and B. And then Y is not exactly in the middle of RS. So Y cannot be exactly antinode. So amplitude won't reach 2 centimeter. Because of that, A is right. Because of that, A is right. So question 28, A is right. Question 29. A two-source interference experiment uses the apparatus shown. what is the main purpose of the single slit? You know that in double slit experiment, we use a source of light like a lamp and a single slit to provide coherent light. That's why C is right. Question 29, C is right. Question 30. Two large parallel metal plates X and Y are situated in a vacuum as shown. Plate X, plate Y, and plate Y. And there is a positively charged particle in the middle of these plates. Plates carry equal and opposite charges. What happens to the force on a positively charged particle as it moves from plate X to plate Y? We know that if there are two plates, one of them positive, one of them negative, between them there are uniform electric field. So electric field is uniform. Because of that, when electric field is uniform and charge is constant, I mean the amount of charge is constant, we can say that force will remain constant because the positively charged particle is in the uniform electric field between the plates. That's why force will be constant. Because of that, D is right. Question 31. For question 31, it is said which diagram correctly shows the electric field lines. We know that for positive charge, electric field is outward. It is radial and outward. For negative charge, it's like that. It is inward. Because of that, for one positive charge and one negative charge, electric field come out from positive and go to negative. So, according to this, we can say that A is right. Question 31, A is right. Question 32. The power output of an electrical supply is 2.4 kilowatt and a potential difference of 240 volt. The two wires between the supply and the kettle each have a resistance of 0.50 ohm as shown. What is the power supplied to the kettle and what is the PD across the kettle? Okay. First of all, I use P equal to IV. So P of power supply is 2400 watts equal to I is not given and voltage potential difference is 240. So I will be 10 ampere. For each wire I can use V equal to IR to find potential difference they use. Okay, V is equal to IR, so I is 10 and R is 0.5. So for each wire we have 5 volt. So for two wires, 5 plus 5, you can say 10 volt. Now 240, which is for electrical supply, minus 10 equal to 230 volt, which remains for kettle. So this is potential difference of kettle. If I use P equal IV, for kettle, then I can say that current is 10 because current doesn't change. So current is 10 and potential difference is 230. So power for kettle will be 2300 watt, which is 2.3 kilowatt. So based on this, we can say that A is right. So this is potential difference of kettle, which is 230, and power of kettle, which is 2.3 kilowatt. So this is question 32, which answer A is right. Question 33, which graph shows the variation of voltage with current for a semiconductor diode? We know that, as we studied in syllabus, I over V for a semiconductor diode is like that. This voltage is called threshold voltage. This is IV graph for semiconductor diode. Now, in this question, they give you VI graph. So VI graph, according to IV graph, will be B. So B will be the right answer for VI graph of semiconductor diode. So B is right. Question 34. 4 different resistors are arranged as shown. A current of 1.5 ampere enters a network at junction X and leaves through junction Y. What is the current in the resistor of resistance 30 ohm? First of all, when current comes from point X and then goes out from this circuit from point Y, I can separate 70 ohm from other resistors. So I can say that these 3 are series, these 3 resistors are series, so I can find effective resistance for them, which is 140. Then the result will be 140 if I connect 2 ends of 140 to 70 ohm. I can see that now I have 2 parallel resistors. I can use 1 over R equal to 1 over R1 plus 1 over R2 to find total resistance of this circuit, which is 140 divided by 3. This is total effective resistance of this circuit. Then I use V equal to IR. I is 1.5, which is 3 over 2, times total resistance, which is 140 divided by 3. If I simplify, voltage will be 70. So what does it mean? It means 70 volt will be up also for down part, also 70, because they are parallel. Now I can say that for upper part, I can say that 70 equal to 70 times I1. For 140 ohm, I can say 70 equal to 140 times I2. If I simplify, I2 will be 0.5 ampere. There is another method which you can find after you simplify this circuit to 70 and 140. Can be an easy way to get 0.5. You can say that 70 is 1 times 70. So I write with blue one. 70 is 1 times 70. 140 is 2 times 70. So what does it mean? It means if I divide 1.5 ampere divided by 3, it gives 0.5. Then 0.5 times by this coefficient, it gives current for 140. 0.5 times by this coefficient, it gives I1. It means current for 70 ohm. So 2 times 0.5 is equal to I1. 1 times 0.5, it gives you I2. So without calculation, these total R and also potential for parallel, you can find current easily. This is also second method to do that. But this long method is better because you don't make a mistake. Question 35. A cell of constant electromotive force drives a current I through an external resistor of resistor R. The terminal potential difference across the cell is V. When the internal resistance of the cell increases, what is the effect on V and on I? Okay. We know that when there is an internal resistance for a battery, V can be electromotive force minus IR. IR is called lost volt for battery. If you increase R, if you increase I, IR also increase. When IR increase, V will decrease. Because of negative sign, because of minus, if IR increase, V decrease. That's why you must choose A or B. Now we should think about current. You know that current is E divided by R plus R. External resistance, internal resistance. And E is electromotive force. In this question, R is constant, E is constant. So these two are constant. If you increase R, internal resistance, then current will decrease. Why? Because they are inversely proportional. When they are inversely proportional, it means if R increase, I will decrease. And we know that electromotive force and external resistance are constant. That's why between A and B, we should choose A. Question 36. In the circuit shown, the batteries are identical and all have negligible internal resistance. All of the resistors have the same resistance. The diodes have zero resistance when conducting and infinite resistance when not conducting. In which circuit is the current in the battery greatest? Okay, for this question, first of all, I should explain if I have two resistors and one battery, if they are identical, then effective resistance for parallel will be R over 2 and for series will be 2R. That's why when R is smaller, then current is larger. So if you consider current for this one is I1 and for this one is I2, so I1 is larger than I2 in the circuit. So consider for this one I1 and for this circuit I2. So I1 is more than I2 because effective resistance for first circuit is less than effective resistance for the second circuit, which are two resistance in series. Because of that, I can say that B cannot be right because for choice B is less, and the question said current in the battery greatest, so B is wrong. So we say that B is wrong. Okay, this is wrong. Now between A, B, C, D, as you can see, current start from the positive end of the battery, conventional current, and come in this part and goes to the resistor. But when come towards the diode doesn't let current to pass. So that's why we have only one R. So R is less than R over 2 for first circuit. That's why current, which is for example IC will be less than I for circuit 1. Okay. Now I consider D. For D also, same thing happen as C. The current can pass from this diode, but cannot pass from this diode. So again, if you consider R, so I for D also is less than I1. So I1 is the circuit of number 1, which is choice A. If you consider R and R, you can see that current can pass from this diode and also can pass from this diode, and it is same as circuit 1. So when R is the smallest, current will be the greatest. That's why choice A is right. Question 37. A thermistor is an electrical component with a resistance that varies with temperature. A thermistor T is used in a fire alarm system. The alarm is triggered when the potential difference between X and Y is 4.5 volt. What is the resistance of T when the alarm is triggered? Okay. First of all, I want to find current of the circuit. So V equal to IR, Ohm's law, I can say that 4.5 equal to I times 150. So I can find I equal to 0.03 ampere. Then I want to find potential difference of thermistor. So potential difference of thermistor equal to electromotive force of battery 12 volt minus, I don't need to write unit, 12 minus 4.5, which is 7.5 volt. Now V of thermistor equal to IR. So 7.5, and we know that current in series are equal to total current, so I can use 0.03 times resistance of thermistor. So if I calculate, I can say that resistance of thermistor will be 250 volt. That's why C will be right. In question 38, it is about alpha particle scattering experiment. You know that the question said which conclusion about the structure of atoms cannot be drawn from this experiment alone. Okay. If you look at four choices, A is most of the atom is empty space. So this is result of alpha scattering experiment. So A will be right. Most of the mass of an atom is concentrated in the nucleus. This is also a result of alpha scattering experiment. And you know that for D, it was electrons, and this is also nucleus. We know that if alpha particle is shooting towards a gold atom, this is a path of gold atom in one of the results. So we can conclude that D also is right. Why? Because alpha is positive. Because alpha is positive. Because nature of the alpha is helium nucleus, that's why it is positive. And because of this deviation, we can conclude that nucleus is charged, and charge of nucleus is positive because of proton. Because inside the nucleus there are neutron and proton. Neutron is neutral and doesn't have any charge, and proton has positive charge. So by this experiment, they conclude that the nucleus is charged. That's why D also is right. So the wrong answer for alpha particle scattering experiment is C. So C cannot be drawn from this experiment alone. So C will be answer for this question. 39. Radon 211 and francium and radium are three nuclides. How many neutrons does each nuclide have in its nucleus? You know that to find neutron, you should subtract atomic mass from atomic number. So you can find for each of them. So for example, for first one, I can say 211 minus 86, which is 125. For second one, 210 minus 87, which is 123. And for the third one, 212 minus 88, which is 124. So based on this result, I can say B is right. For question 39, B is right. Question 14. A neutron is composed of one up quark and two down quarks. When the neutron decays to a proton, there is beta emission. What is the charge in the quark structure of a neutron due to the beta emission? Okay, we know that neutron is 1, 0. It gives, when decays, it gives proton p11 plus electron plus antineutrino. This is for beta emission. And we know that if proton decays, it gives neutron plus positron, which is electron with positive charge, plus neutrino. So this is for beta positive decay emission. So based on these two equations, we can say that B is right, because beta negative, which is electron, gives antineutrino, and also B is right because when proton decays, it gives neutron, positron, and neutrino. So question 40, B is right. Okay, thank you very much. You can watch other videos of past paper of AS in the near future. Thank you and goodbye.